Hanselminutes.com. It's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman, hosted by Carl Franklin. This is Lawrence Ryan announcing show number 146, recorded live Monday, January 12th, 2009. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. And by .NET Developers Journal, the world's leading .NET developer magazine. Online at www.sys-con.com. In this episode, Scott talks test-driven development with Scott Bellware.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes. And in this episode, we're sitting down with Scott Bellware, an agile coach from Austin, Texas. And he proposed that we talk about test-driven development, but specifically he wanted to call this talk Test-Driven Development, the Last Word. Because Scott has some really interesting opinions about how TDD is being perceived and being preached in the community. So I thought that'd be a real fun discussion. Thanks, Scott, for sitting down with me today.
Yeah, thanks for having me on.
So the last word, that really implies that test-driven development is being presented in a way that's not entirely accurate, and we want to kind of slam the door shut on that and move forward. So what is not being presented appropriately with regards to TDD in the community today?
I think that it's pretty well represented fairly accurately. The problem, I think, comes in when we leap to the assumption of testing. Every time that we start talking about test-driven development or these conversations about software testing or software quality assurance, it's almost inevitable now that someone will turn the conversation to test-driven development. Let's talk about quality. And then, what do you think about TDD and how does this apply? And I think some of the little bit of the shocker for me, and maybe it's a shocker, hopefully, for the audience, is that folks who do test-driven development assert and have asserted for quite a long time that TDD is more about design than about testing, and there's a little bit of benefit to come about talking about TDD when we're talking about testing, but only as talking about the side effects, the quality side effects of TDD, and it's so I think egregious, or has become so egregious over the years that TDD has even been somewhat renamed in recent times to from test-driven development to behavior-driven development, really to draw a line in the sand and say, this is not about testing. This is about something else. We've got this unfortunate heritage of TDD that has the word test in the name, but it's not. And we should really endeavor, I think, more of an effort to preserve the intrinsic value that TDD offers and TDD has, really give it the old college try to say, hey, every time I'm talking about testing and I feel my mind wanting to stray to TDD, maybe I should program myself to throw an exception or something like that.
Well, I think that the simple name test-driven development describes the mechanical action of this style of development. Yes, one does tests. Yes, an aspect of the test drive development, but that's the physical aspects of things.
And it's a bit of a gray area too, because even if I say this is about testing, this is about design rather than testing, there's always going to be an aspect of testing in TDD.
Right, but to write tests and have them drive the development isn't necessarily the purpose. The whole reason for existence of this style of development. I haven't felt though that behavior-driven development. Well, it seems like it feels better to say for me. It still doesn't quite say it right. You know how they always say in object-oriented programming, you need to really name it before you can understand it. And I almost feel like we haven't named this style of development in a way, at least for me, that resonates.
I think that there's a behavior-driven development discussion group on Google Groups. I don't remember the address right now, but I'm sure you can Google for it.
Sure, we'll put it on the show notes.
And that same thing is reflected in behavior-driven development. I mean, not only did behavior-driven development change the name in order to try to resolve this issue about TDD and testing, but it also is 10 years later, and some of the practices have been changed, and it introduces its own set of confusion, as any new thing or new practice does. So it's questionable whether the name, actually does anything except change the name from test-driven development. And I think that there's great value in that. I think it's also quite sad, though, that no matter how often it was brought up or how often it was pointed out or even requested of folks to really consider TDD as testing rather than, as design rather than testing, that it never really sank in. And I find this fascinating. I think that questions and conversations about quality are sometimes even damaged when we let them fall over into conversations about test-driven development. If you look at writing tests first as a means to achieve software quality from the perspective of a tester's perspective or a quality assurance perspective, it's going to seem pretty senseless. TDD will create quality, but not the kind of quality that, the word quality applies in a different way. I thought it was fascinating listening to Carl Franklin's conversation with Dr. Whitaker, and it was a pretty good episode of your brother show, .NET Rocks.
.NET Rocks.
And I hope a lot of people get a chance to listen to Dr. Whitaker's perspective. The only, some of it I agreed with, and some of it I thought it was a little bit sci-fi, and that's kind of, that's great. At least it was engaging, and I appreciated that. But when it got to the test-driven development question, it was, to me, internally one of those things like, hey, why is test-driven development coming up in the conversation about software quality and software quality tools? And for me, it's natural to think that way, and I think it's natural to think that way for many folks who do test-driven development. But it's really kind of hurting test-driven development and the value that it brings, and I think it also hurts these conversations about quality.
Okay, so let's try this thought experiment. Let's back up and let's go from the point of view of someone who works in. Let's use my canonical engineer. This is the guy that I call the chief architect at the Nebraska Department of Forestry. And he's got access machines, and he's learning ASP.NET, and he maybe started out as a VB guy, but maybe doesn't really have the deep computer science passion or the deep software engineering passion that a lot of people have. He's just a guy who's got a job, and he enjoys it, but he really wants to be a better person. This is, 70% of developers out there. They want to do better, but they're saddled by some issues, whether they be organizational or technical or whatever. He starts a new project, and someone says, hey, wait a second, you need to be writing the tests first. You need to let the tests drive the development, and then they give him the elevator speech on test-driven development. And what I'm hearing you say is that he's going to immediately say, oh, okay, well, this will mean that I'll have lots of tests, and I can go to the command line, I can type build.bat and test.bat, and I'll have more confidence that my application works. And then he goes on with his life. And you're saying that is completely missing the point. He's missing an opportunity here.
Well, I think if he's trying to get the opportunity that test-driven development brings to the party, that he's very possibly missing the point of test-driven development. That in the summary that you just presented, it didn't really sound like the case for test-driven development was made.
No, it doesn't, but that's very typical. I mean, I've lived through those experiences and lots of times where someone is introduced to test-driven development in a very basic sense.
Well, if you introduce it, I would expect anybody to balk if I walked up to them and say, hey, this new unit testing thing, let's do that, it's really good. And that person says, yeah, I've heard of this, that's a great idea, I've wanted to do this. And then I say, but let's start writing our tests first. There's no real sort of rationale or logic that suggests, that leap from, doing unit testing to writing tests first. And part of the reason for that is the goal here with test-driven development isn't really a unit testing goal, although we're borrowing unit testing tools to achieve the goal, and thus test-driven development. And frankly, there is testing involved. I mean, we are using testing. We're borrowing testing, almost like we're, sort of demonically possessing unit testing to achieve other means, So I don't think I could sell test-driven development from the perspective of the value of unit testing.
Okay. So how do we frame this? So the guy, someone's got some foray into testing. He's done some testing, he's done some basic stuff, but it hasn't taken over his life. It hasn't fundamentally changed the way he designs software.
Mm-hmm. Well, the first thing I would want to do to frame it is ask whomever I'm working with to just give it a little bit of effort, that every time they hear the word test-driven development and they automatically react with thinking about testing and quality assurance, that they just suspend disbelief every time that moment comes up and just give it a moment of pause and consideration. That goes a long way to understanding what we're after, or to disentangle testing from the goals of TDD or BDD.
Okay.
The next thing is to talk about what makes software great and enjoyable to work with. And the basic premise is, for me, that you can't really use anything that you don't understand. So if software is hard to understand, it's going to be hard to work with.
Uh-huh.
So the easier that we can make software understandable, the better our experience as developers, and also the higher our productivity will be. It's interesting that the qualities that make software easier to understand are also the qualities that are highly desirable from a OO design fundamentals perspective. So when you spoke to Bob Martin about the solid principles, at a very, very basic, abstract, and essential level, all of those principles point to designs that are easy for the human mind to get around.
You know, that's funny that you mentioned that, because I run my, this is going to sound random, but I think it makes sense. I run very large fonts. I have a really big monitor. Everyone's got a really big monitor, I've got multiple monitors. But I run like 16-point font. People think that's ridiculous. Why do you run a 16-point font? I run a 6-point font. But I really get uncomfortable if I can't see the entire function without scrolling at 16-point font on my monitor, which basically adds up to about 25 lines. If it gets bigger than that, then my small mind just can't conceive of what's beyond the scroll bar. And I find that it makes what I do better, and I've almost kind of like mechanically forced myself to have smaller functions, just because I can't possibly suck that much information in at a time. And
so you're pointing to an essential quality of code that's easy to understand, which is it's small,
right?
Or there's less of it to swallow at one time,
right? And then if you start there, consequently, it's easier to test. And if it's really small, hopefully it has only one purpose to live.
Yeah. So what was the solid principle?
That a class or method should have only one reason to change.
Yeah, the single responsibility principle. Now, all of this jargon, test-driven development is also part of the jargon. Testability is one of the worst bits of jargon. It's one of the most accurate bits of jargon we have, and it's also, I think, one of the most, destructive bits of jargon to the cause of software design. When I say testability, or when anybody in the progressive, for lack of a better word, software development community uses a word like testability, it means something inside that community, inside that culture, and it means something that is not understood outside of that culture. Every programmer in the world should reasonably assume that when I'm talking about testability, I'm talking about the ability to test something. So if I look at some piece of code, or if I sit down with Joe, programmer from Nebraska Department of Forestry, and I look at his code and I say, hey, that code's not testable, and he says, you're out of your mind. I'll show you the tests for this. As a matter of fact, I've got high coverage on this code, and this code is tested, so it must be testable. I've kind of sort of shot myself in the ideological foot by using this word testability. Right. And the assumption that we make in the inner sanctums of the echo chamber is that we're really saying it's got easy testability.
Right, and I think that point that you just made it kind of deserves repeating and paraphrasing and pounding because I think that it really clarifies things for me. And I think it really nails the point. The idea that you did test something and it doesn't mean that it was easily testable. And I remember when I talked to a guy named Ketzel Bradley, who's a tester at Microsoft, who made the comment to me, what do you think it was a year ago when I talked to him, that just because you have 100% code coverage, that doesn't tell you that your code works necessarily. It just means you executed every line. It doesn't say anything at all about intent. And it's these small little obvious observations that continually blow my mind when someone says that, I had a guy on my team who was obsessed.
But that should never be taken to mean by any of your listeners that code coverage is thus irrelevant.
But I had a guy on my team who was obsessed with getting to 100%. And I thought it was great. I was like, all right, well, if he wants to work that hard and get to 100%, good for him. But it made him feel good, but it was a completely false sense of security.
I think 100% code coverage is a pretty good number, to tell you the truth. I think it's a really good number when that number comes out of a team that's using a handful of practices that make that number mean something. That number on its own only means something when you're using the kind of designs that suggest that the number is meaningful. And this comes back to design again, right? If I get 100% coverage on code that has what I would call defect attractor design, then you're really not proving that the code doesn't have defects. You're just proving that you've touched every line. But if you had 100% coverage on code that was well designed, it actually starts to mean something more in terms of what you can expect from a defect rate. Certain designs are more prone to defects. They attract defects than other kinds of designs. And the smaller and smaller, and the more cohesive these units of functionality become, in accordance to all of these crazy grandiose terms like testability and the solid principles and so forth, the less amenable they become to attracting defects.
Hi, this is Scott, coming at you from another place and time. Are you looking for an object relational mapping tool for mission-critical projects using LINQ and .NET? I wanted to share with you Genome. It's specifically designed for developing .NET Enterprise applications. Genome is a mature LINQ-integrated ORM tool. It's been employed in numerous large-scale projects over the last 6 years. Genome was created for the .NET platform as opposed to being a port from Java, and it's thrived on platform innovation since .NET 1.0. Genome has supported LINQ since its CTP release in May of 2006. It offers several unique features such as encapsulation and reuse of LINQ queries and expressions. You can really fully harness the power of LINQ while benefiting from your database platform's unique features. Compose complex LINQ queries, decompose the query logic in your domain model. LINQ supports all the major database platforms you find in enterprise environments like SQL Server, but also Oracle and IBM DB2. You can find out more about how Genome integrates tightly with Visual Studio and what tools Genome offers to reduce development time at tinyurl.com/trygenome, GENOME, where you can also download a free and fully functional trial version. I hope you enjoy it.
Okay, so are there some specific things to watch for this defect attractor design? Because sometimes when we, the echo chamber or whoever, talk about these things, it is very vague and it's very difficult to take these generic concepts and apply them to something really explicitly and point to a line or point to something. Is it folly for us to try to look for something really, really concrete when we say, well, all right, well, I understand what you're saying, Scott, but let's get specific.
Here's an example, right? It's interesting. I think that on your show with Bob Martin, he gave a really interesting example of what I would think of as a defect attractor, or a design with a potential for defects, which was when he talked about the substitution principle, the Liskov substitution principle, and he gave the example of a collection of objects that have a base class of square, and somebody implements a rectangle class to be a subclass of square, and then at a higher level, there's another programmer writing code that iterates over a collection of squares and calls methods on them, but the rectangle has different behaviors because it is not it's not a square.
Mm-hmm. Yeah, I thought it was a great example. But the idea was that one's observations about kind of reality don't necessarily always translate and get easily modeled in software. And that was just a perfect example of, here's something that you know how it works. You've known since 7th grade, but you can't model it like this.
Sure, but the specific example he talked about in the code, where he would have a collection of types whose dynamic type is a base class, and then you operate on them, and you should be able to operate on any type. But then he said, well, we have this special circumstance, and when one of those items, when we're iterating through, and the current item is a rectangle, then there's an if statement there, and then the if statement has to do some special processing. That special circumstance that is at that level of the design is likely a place that will cause some sort of defect to happen somewhere else. And the reason for that is it's unexpected that it's there, and it's hidden knowledge. And this goes back again to knowledge and learning and design. So all of these great design qualities and all that test-driven development does is drive for the simplest units of understandability, or the simplest units of the things that your brain can dissolve into itself and turn into knowledge and learning. And you can see this very easily in some of these practices in test-driven development. We're really trying to drive at the smallest amount of setup code. So if you have a piece of business logic that has an if statement in it that on one branch of the if, let's say, creates a new database row, but on the other branch of the if updates a database row, then you might have to set up that test, right, you'll need a database. You might need some sample data if you're in the update branch. You might need, and then, of course, on both cases, you'll need to query that row out of the database to see if it worked. Well, the presumption there that you need to have a live database in play to test the if statement, that the if statement worked based on the variables that it was checking, is the kind of presumption you get to when you have large designs, large chunky designs, when you don't have modules or modularity.
Right, and at that point it knows too much. You're starting to bump up against single responsibility. You're stumbling on a design smell.
Sure, but even if we don't go into that terminology, I could look at the test code and see something that is often referred to as test friction, which is the amount of setup code necessary to run this specific scenario is more than we find comfortable, because I have to create database rows, I have to set up objects in the database, I have to set up a data access layer, all this kind of stuff. So if you look at what it takes to take any old object in your system, instantiate it into memory, and then poke and prod at it and learn how it behaves, the amount of effort it takes to set up that code, that's kind of one of the most important things that we're driving at test-driven development. It's how much effort do you have to make before you can learn what an object does?
Wow, that's a really good way to put it. How much effort do you have to make before you can learn what an object does? There was a couple of years ago, you and I were having a kind of a lowercase a argument discussion about a word that you used that I think really means a lot right now, which is called solubility. Yeah. Which is how easy, how little friction is there between the design and getting it into your brain? Do you have to chew on it for a while, or does it just kind of grok immediately and suck into your brain and just smoothly, like drinking water?
Well, if you look at designs that require lots of setup to use them. So the H, I said H like a Canadian, because I am, but I never say H. Don't tell. The HTTP context object is a sort of classic, the classic example of a design of a manager object, right? The very big, chunky, multi-rolled. It's a Swiss Army knife that never ends.
It's always there. It's in the background. You can pluck it out. It's implicit parameters. It's just ever present.
But how can you ever instantiate one in memory? So let's say this. This is a great example. If I had a code behind page for an ASP.NET Web Forms application, and I wanted to test that, my ideal scenario would be to instantiate the code behind class in memory, and call a method on it, and then I could see the text that was rendered from the code behind, from the method. That's really not possible, and it's really difficult to understand what a code behind page does and to learn what it does. And there's, articles and books written on what we think of as what is the pipeline, people call it traditionally?
Right, yeah, the HTTP pipeline and all the eventing and stuff, because things are getting called kind of via magic.
It is, and it's that black magic. So when we go back to the scenario of the business logic that calls the database, where the if statement in the first case in the first branch might do an update and the second branch might do an insert or what have you, if the business logic has a dependency on this database module, then that dependency has to be made very clear, very obvious, very transparent. Let's say in that business logic module, the constructor instantiates a database access class, a DAO object. Now, if it does that instantiation in the object, then you can't really tell from the outside of that object that that's what's going on.
Right.
So when I start, say I instantiate that business object class, and I start poking and prodding at it to see how it works, I'll probably get a null reference exception or some crazy thing that happens once the code hits the DAO, right?
Yep.
That's what you would think of with more esoteric terminology as an opaque dependency. Those things make it harder and harder and harder to understand what that business logic does. Does that make sense?
It does. It makes total sense. So I'm used to things like Kent Beck's term code smell. We all like that. It's a great way to just say, this isn't right. And I think that there's definitely test smells, and you're describing kind of design patterns that are really design anti-patterns that then spill over into testing. So you've got, all sorts of test anti-patterns or test smells, like you just said,
sure.
A lot of context, a lot of, implicit context that's coming in that's not being passed in directly from a parameter. You've got lots of setup code, anything that's in any concept like a session where you're plucking things out of some holding area outside of yourself. Outside
of the concern of the test.
Thank you. Outside of the concern.
So if we're talking about this business logic module that has an if statement in it, if the data access layer, if I want to control which data access object goes into the test so that I can verify how it was used, I could make the data access object a singleton object. So I would call, instead of calling new on the data access object, I would call get instance. But I could have a hook in that class that says, here's the instance I want you to give. So I'd set up the data access object with an instance of the data access object so that when it returns, when some code in this constructor of the business logic module, and this is really, I don't think, coming across in a conversation as well as it would on a whiteboard.
Yeah, I agree.
But if you have to set up, if you have a registry of data access objects that you use, and you have to set up that registry, then you're not actually setting up the business logic object. And that is a code smell. If you're setting up factories, and if you're setting up containers, and if you're setting up these registries and session state and all of this stuff, you're starting to bring in concepts into the setup of a test, and let's not say test, the setup of an object that bring in more concepts, more issues, more classes. HTTP context is, a classic example of this. If you wanted to use an HTTP context, then you'd have to set up a lot of stuff before you could even test the thing that you're actually concerned with, which is the operation in a code behind page or a code behind class. So all of these ancillary concerns that we have to bring into our test, this is test friction. This is,
exactly.
Hey, I want to run, my ideal scenario is I want to run the click method on a page, and I just want that to work. I want the design behind all of this to be fairly simple so that I can just make that happen. So there's a framework in the Ruby world called MERB, and when you test for all intents and purposes, a web handling method, you just call it. You instantiate the controller and call it, and that method returns text, and the text is the web page, and you can inspect the web page. There's nothing more simple than this. There's no true deep necessity. I'm oversimplifying, but there's no real deep necessity to set up all of this ancillary stuff. It's the ancillary things that we have to set up the objects before we can get them in memory in a good state so that we can start to learn from them. Mm-hmm. That's what the noise is. That's what the test friction is. And any really good programmer should be able to say, yeah, but I'm a good programmer. I'm not really daunted by that. I'm beyond that. My skills are such that I can handle the pain. I can take the pain. But the reality is we tend to stop considering the other people on the team who are coming into our code, likely from a cold start. I've never seen this code before, or I have just been away from this code for a couple days or a couple hours, or whatever that time span is that reflects how quickly my memory fades.
Yep, and then you get yourself into a situation where you're working on a design, and I always call this a write-only design. Where you can slap the keyboard all you want, but no one's going to come in and ever read this and figure it out. It is write-only. Well,
the problem with sort of judging whether or not the thing that you did is good is that you're judging it from having, your brain is already warmed up to it. You don't see how difficult it is to come at it from a cold start because you yourself are not in a cold start position, right?
Yes.
This is the problem of creating usability or user experience. When we create a user interface, most of the people who create user interfaces that end up being user interfaces that are thought of as poor user experiences aren't really sitting down to say, hey, this is a poor user experience. They really kind of look at it and say, hey, this works. This is good. I think this is good. I'm going to go with this. The reason for that is they're already warm.
Yeah, that makes total sense. They're warm. They have already positive attitudes towards the thing. There's pride. There's ego involved.
So knowing that happens, and it happens to every developer, not just, the best developers are some of the worst user experience people because they have such a powerful facility of memory that they keep this mental map of the system in their mind, right? And they say, well, I know where all this is. I don't really need to create smaller objects just to help create mnemonics. And the reality of the scenario is that's the minority of developers, right? That's the hero developer, the developer with the photographic memory. The reality of the world, the rest of the world, is most developers benefit from dealing with objects and systems of objects that are much smaller. And when they get smaller, and when we apply some of these, let's not even talk about applying design principles. If they're smaller and you can set them up in a few lines of code, so write down some example code and set them up and poke at them and see what they do, well, you've got software that's learnable. And like I said, coincidentally, that software probably expresses the quality of testability that people talk about in the developer testing community, and it also will more than likely express many of the solid principles. And if you just make the effort of writing down some sample code saying, here's how simple I want setting up this object to be. I don't want it to be any more complicated than this. If you make that effort, then the resulting implementation of that example that you just wrote of the level of simplicity that you want, the implementation will more than likely necessarily reflect solid principles. And I can say categorically that most of the people that I know that I learned or that I came up with in OO and TDD didn't really start from the perspective of, hey, here's this great acronym from Bob Martin, and here are these definitions of object-oriented design principles that we found on Wikipedia. We kind of backed into those things really backed into them, like kind of backing up, kind of like one of those cliched Scooby-Doo scenes where, Fred's backing up and, Scooby's backing up and they bump into each other and they surprise. Like, we backed into all of these design principles and said, wow, look at this code that we're creating. It actually reflects these things that other people said are really good and desirable. And from the perspective of looking at the code we created, we really began to get a good understanding of what these design principles were. And then we started leveraging them explicitly and purposefully. But you don't really have to go at it from solid. It's great to know what they mean. Mm-hmm. But if you just write these little examples of simplicity out, you'll go a long way. And that is what test-driven development is.
Now, is that why, is the idea that you would write down an example, say, this is how I want it to behave, this is how I want it to look, see how easy it ought to be, is that why is that behavior-driven development? I'm saying that it should behave like this? It should be this simple? It should be this basic?
I think behavior-driven development, and I can't speak for Dan North, it'd be valuable to hit up Dan North about why behavior-driven development is called behavior-driven development. But there is a notion in specification, and by specification I mean test, which is sort of specification is terminology in BDD for test. Mm-hmm. We are really interested in developer testing, in unit testing, in testing behaviors, because it's the value of the system is the things that it does.
Exactly.
So we are doing our analysis from the perspective of behaviors. We're doing our design from the perspective of behaviors, kind of like this entity pattern or entity objects. We tend to call them behavioral objects. They're really there to represent clusters of behavior. Bob Martin talked about this in his conversation with you about single responsibility principle. He's talking about creating smaller objects that have more smaller sets of behavior that they represent.
He wanted them to do less, really.
I'm sorry. Right, I got distracted. Yes, they have less groups of behaviors. They're not just sort of objects named person manager where we hang every concept of person off of this object,
Right.
That kind of idea of a person manager class is really a procedural programming pattern. It's the person function library. So BDD helps us to focus our minds on this essential aspect of software, which is the logic. And so did test-driven development as well. It was just it's just really hard to talk about what test-driven development is because people keep getting really snagged and hung up on this word test.
Yeah, I think it is a little amorphous, but I feel that you've definitely enlightened me, and I feel more like I'm kind of circling the drain here. I think I'm heading in the right direction. I think that I can use this information to get a better understanding about test smells, about when a test doesn't feel right, and a test smell inevitably points to a design smell. And
absolutely.
And then underneath that, I may or may not find code smells. But if my tests if there isn't joy in writing my tests, if I'm doing lots of setup, if my tests are full of friction and pain and I don't enjoy writing them, then there's something wrong with my design. And that kind of is, regardless of what we call this thing called TDD or BDD, that is the kind of the essence of test-driven development, to unearth those things and to discover that not that there's a problem with my test, but that there's a problem with my code. My design is not sufficient if it can't be used effortlessly.
And above and beyond that, this notion of effortless setup and effortless exercise, the side effects of this, like I said, are the solid principles. And the solid principles just aren't about testability. We use the word testability or easy testability to describe it. But really, the ability to do the things with software that we want, to leverage it in more meaningful ways, comes out of these principles. The ability to decouple software and distribute objects in service-oriented architectures. The ability to use plugins to do provider pattern kind of stuff. The ability to scale and parallelize also comes out of these in object-oriented systems. Also comes out of these principles. Once you get at this sort of, quality of design, all of the other things that we need from design, that we require from design, become much more readily available as a side effect. So we're going to focus on writing sample code that shows how easy it is to set up and learn from an object. And the benefit from that isn't just testing, it's high-quality design. And even if you don't know how to do high-quality design, and everybody who's done test-driven development for a long time will say the same thing, even if you don't know what high-quality design is, if you start with simplicity and expectations and demands for simplicity, you're going to end up at high-quality design, or at least higher-quality design. And the more you do it, the more this will just become automatic. And it's amazing what doors to knowledge about design this practice opens up. And like I said, no one has to start memorizing the esoteric terms and their meaning. And frankly, those terms and those meanings are going to make a whole lot more sense when you've written some code that demonstrates it.
So what are some resources or some books or preferred ways that people can dig into this, some actions that they can take after listening to this podcast? Are there is a particular Bible that you think people should read?
I think there's a mantra that we can start with.
Okay.
If we just get people to say, test-driven development is design. I guess
test-driven development is design.
That's a good place to start. After that, there are so many resources about test-driven development, but most of them, I think, are written for people who are already into test-driven development, unfortunately. Mm-hmm. The lure and the love and, the almost addiction to words and terminology of test-driven development and object-oriented design immediately create an echo chamber. I think saying fancy words produces serotonin in programmers' brains. And I'm definitely guilty of this. But the problem is that it makes it harder for people who don't know these terms. So most of the really good writing is written for an audience that is already somewhat initiated. The book that made it really turn on for me was James Newkirk's book in MS Press. He might be screaming, at his iPod right now, but that his book Test-Driven Development with Microsoft.net or in Microsoft.net is a pretty good set of exercises to try to get used to .NET. And I think Jim said recently that somebody needs to rewrite that book, and it's a fairly I guess from a technology perspective, timeline perspective, it's a fairly aged book, but it's the only book I've seen for .NET programmers to start fresh. Aside from that, there's lots of podcasts, and there's lots of blogs on Los Techies, on Code Better, and sites like that that try to explain test-driven development. But it's very, very difficult to explain something that has to be experienced firsthand.
All right. Well, thank you very much, Scott Bellware, for sitting down with me and talking about test-driven development. And we remember now that test-driven development is design. This has been another episode of Hansel Minutes, and we'll see you again next week.